One of our most valuable features of the Tinder is that it's redeployable. I'm not saying you want to move it from machine to machine for different jobs, but if you find you have shifted from a mill heavy shop to a lathe heavy shop, or you found a new bottle, and maybe you found a new bottleneck, you can evaluate the pros and cons of moving the existing automation solution from a mill to a lathe, or from a lathe to a mill, uh, or even mill to mill, whatever it is, at a minimal investment, making the most out of this investment. Here we see our Tinder base with the milling shelves in front of an Akuma LB3000. This one has the 800 millimeter bed, but again, in this configuration, it's not going to help us much on the lathe. So we are going to remove the shelving system, and then we will insert, or we'll replace that shelving system with a sheet metal layout designed to accept 3D printed sockets. We chose 3D printed because uh, they're fairly affordable and they have very minimal design restrictions. So here we can see one of these 3D printed sockets, and of course they go 8 across in this size, and then we go here, we can go 12 across as a second option. So here we have a 2.5-inch on center. Largest part for this would be obviously under 2.5 inches, probably 2.4, 2 3/8, somewhere around there. We'll say roughly 2 3/8. Our offset on the 12s is 1.6, so we would probably limit this to about 1.5 inches, maybe a little under 1.5 inches diameter. Looking further into this design, I'm going to go ahead and turn off the Tinder and our sheet metal and the beautiful LB and our 12. Let's go ahead and talk more about the second row here. So this would be an example of a printed socket. Your stock can go inside. And again, we have 8 across. Well, at least we should. Second row. Maybe it's all underbodies. So we have 8 across. And then in this one, we see I put some holes in here. Most of this is concept based, but we can print or use maybe we just use a 1/2 13 socket head cap screw. They're fairly affordable, maybe a 1/4 inch, whatever. But you can put a feature into your tube to allow different lengths of parts and utilizing that same 3D printed tube. Go ahead and turn that on because I like seeing stuff. Okay, so then we can move on to our smaller 12 offset parts. Again, looking at about a 1.5 inch part diameter difference here. If we were to look at some kind of extruded face, this teardrop feature allows the tube to settle into a repeatable position, and then also allows the robot room to pick up and pull out, and move into the lathe. When we go from the 8 pieces to the 12 pieces, ultimately we increase part density per row by 30%, a little over 30%. But the best part is when you get to parts underneath 1 inch diameter, we can split that. We can split that 3D printed socket into an upper and lower, and then double that part density. I picture this being perfect for like a centerless grinding application where you have maybe smaller parts and a lot of them, and we need to pick them up, put them inside that grinder, and let it do its thing. So going ahead and moving on here to an example. So we're going to use the 8 position. Let's see if I go here. We have a 1 5/8 round stock, 7.5 inches long. We've got it in a 3D printed socket. We're going to put it in front of our LB3000. And here in this configuration, you can see we have 96 parts on this face. We have 4 faces. So in this configuration, we have 384 parts in the parts tower, or in the tender base, ready to be loaded in and out of the LB3000. Then potentially the if you need more part density, we can add an additional tower. This tower has 14 vertical options instead of 12. This is 12 high by 8 or 12 wide. So we have 14. We go to the parts tower because it is a taller part. Add those printed sockets and some stock. And now, again, 8 times 14 is 112 parts per face, 4 faces. So that's 448 parts in the queue just off of the parts tower. And if we want to do some quick math here, for some reason I didn't do it before, 448 plus the 384, it's going to be 832 parts in front of this LB3000. Now this example assumes a low mix, high volume, but the second best thing about the tender is that we actually focus on high mix, low volume, and we do that by dividing each face up. And so here you actually have 8 faces that can hold 8 different parts, and controlling that program be done with some simple logic at the machine. The end of arm tooling is not modeled in this configuration, but we do have dual grippers on the end of arm that allows for rough stock turning to be loaded, and then if you've turned off that face, we have that second gripper to pick up the turned face. The other thing it allows us to do, even if we can grab the rough stock and the finished turn stock with the same gripper, we'll have a rough stock part in the robot's hand, go in, grab the finished part, and switch out the parts without having to come back and forth to the tender, to the parts tower or whatever during that cycle time. We also have part blow off capability. See if I forget anything off my checklist here. If you have any questions, please contact me or Jason. Thanks.